In this presentation, we're going to look at number sets. So the first thing we're going to do is first off talk about Blackboard Bold typeface. So the symbols for our number sets are conventionally written in this typeface, which we call Blackboard Bold. And there we have three examples of it there, N, Z, and R. So the way that those symbols are written, the typeface is called Blackboard Bold. Okay, so the natural numbers, we have the natural numbers n, and these are simply the whole numbers from 1 onwards. 1, 2, 3, 4, 5, and 6. In some branches of mathematics, though, you might count 0 as a natural number also. But that's the sort of, it's conventionally they start at 1. Now, the integers are the next type of number set. So the integers are all the whole numbers, all the negative whole numbers, and also 0. So that's a sort of like an example of a few a sequence of integers there: -4, -3, -2, -1, 0, 1, 2, and 3. On the left hand side we had this means this these dots here means all the negative numbers less than -4, and all the negative integers less than 4, -4, and these dots over here on the right hand side indicate all the integers greater than 3. So the notation Z is from the German word from numbers. I'm not quite sure how to pronounce that, so I'm going to have a guess. Zahlen. And the reason we use Z rather than I is because I is reserved for a different number set called imaginary numbers. Now, all natural numbers are integers, so we could sort of say that Q is a subset of Z. So if a number is a member of Q, necessarily it is a member of Z also. So all of the numbers of Q are also numbers in Z, the number set Z. Now, natural numbers may also be referred to as positive integers and denoted Z plus. So just to make a remark on this little superscript there, okay? And likewise, the negative integers might be denoted Z minus. Again, look, you can sort of see that superscript there. And if we're talking about Z minus, this is what we might be looking at here. -4, -3, -2, -1, and so on. Okay, all the numbers less than -4. All the integers less than -4 even. Okay, 0 is neither positive nor negative. So if we wanted to write out the number set there, 0, 1, 2, 3, 4, 5, and 6, and so on, we might denote that as the 0 union Z plus. Now that U symbol there is the mathematical symbol for union. Okay, so that's a matter from set theory. It's pretty straightforward. So moving on. Rational numbers. Now they're also known as quotients. And the reason they call quotients is, I mentioned that is because that gives an indication of why we use the symbol Q. There are numbers that you can make when you divide one integer by another, but apart from dividing by 0. So if a number can be expressed, it doesn't have to be expressed, but if it can be expressed as one integer divided by another integer, then it is a rational number. So that's how we might write it out mathematically. Q equals P divided by Q, where P is an element of Z, Q is an element of Z, that is to say P and Q are both integers, and Q is not equal to 0. Okay, so that's how we might write it out mathematically. All integers are rational numbers. So the previous statement there about all natural numbers being integers, this is something similar here. All integers are rational numbers. So Z is a subset of Q. Also, N would be a subset of Q also, because N is a subset of Z. So here's some examples of rational numbers: 9,500, 7, a half, 1 over 2, 3 over 7, -2.6, which could be written as -26 divided by 10 or something like that, and 0.001. So those are all rational numbers. Irrational numbers are numbers that cannot be written as the ratio of two integers, or one integer divided by another. So two famous examples, one would be pi, and another one would be the square root of 2. Those are just two easy examples that most people will know pretty quickly. So there's no easy way to write that. There's no way to write them as the ratio of two integers. You can get a rough guess. Like some people would use 22 divided by 7 for pi, but it's not actually correct. Anyway, it's very close, but it's not it's not actually 100% correct. So those are irrational numbers. So any number that is not a rational number is called an irrational number. So the last type of number type is real numbers. So irrational numbers and rational numbers, they are types of real number. So Q is a subset of R. The irrational numbers are also a subset of R. And simply, a real number is any point somewhere on the number line. Minus 1.125, 2.25, 1000, million, minus a million, minus a million, 0.001, whatever. Any real number is a real number is simply any point anywhere on the number line. Okay. And there are other types of numbers. I mentioned this briefly earlier on, imaginary numbers, but we're not going to cover them in this presentation because really this series of presentations are to do with discrete maths, and you would not really see imaginary numbers on that. So that ends our